at the treatment system influent structures where the wastewater is gravity fed from the park to the lift station. The lift station then force feeds this inlet manhole where then it gravity feeds through the bar rack. The bar rack purpose is to screen out the large plastics, any type of materials like plastics, rags, rocks, anything that's large enough to get bound up in the pumps throughout the system. Reason for that is the pumps in the systems are not grinder pumps, so they can be bound up and ruined. From here, the wastewater then is gravity fed and flows to the primary clarifier. We are at the primary clarifier where the flow is gravity fed from the bar rack into the inlet structure of the primary clarifier, which then flows in this direction. In the primary clarifier there are two hoppers. In the two hoppers there are geyser pumps. The purpose of the geyser pumps are to waste sludge from these hoppers on a daily basis to the digester basin. How that occurs is that the geyser pumps are operated automatically on a timer control, which then the timer control then activates these small air compressor pumps, which then activates the geyser pumps. The purpose of the primary clarifier is an important one. If the primary clarifier is operated efficiently, it can remove up to 70% of your BOD and total suspended solids, which basically weakens the wastewater going into your algae wheel system. How to operate a primary clarifier? There's 2 points. One is to waste the sludge on a daily basis. Make sure your hoppers are clear of sludge every day. And also to clean the surface of the clarifier, clean all scum off. By doing that, you use this wheel structure by turning the wheel, which lowers a skimmer, then skims off, and the scum then is pumped over to the digester system along with the sludge. The effluent of the primary clarifier then flows over a weir in this outlet structure over to the diversion structure. The equalization tank works hand in hand with the diversion structure in preventing a hydraulic and/or organic overload in your algae wheel treatment system. There are 2 inlet points for your equalization tank, one being the effluent from your diversion structure and 2 being your supernate from your digester when decanning. The equalization tank pumps are activated by timer controls in which there are a standard and a peak timer. If the flows are in excess that will rise enough to trip a float, the peak timer will then be activated, in which the pumps will operate more frequently. The effluent from the equalization tank goes over to the diversion structure. The diversion structure receives the primary clarifier effluent. The purpose of the diversion structure is to prevent hydraulic and/or organic overload at your algae wheel treatment system. What happens is there's a slide gate in your diversion structure that you can adjust up or down depending on how much flow you want to receive in your primary algae wheel system. Any flow that flows over the weir will flow over to the equalization tank where it will be recycled to end up back into your algae wheel treatment system. The primary algae wheel basin receives influent from the diversion structure into 5 inlet points. There are 5 separate bays, 45 algae wheels per bay. The algae wheels are operated by air from a blower, in which there are diffusers that are run underneath each algae wheel bay. The purpose of the primary algae wheel system is what we call the carbonaceous stage. It needs to remove the BOD first before it can attack the nutrients such as nitrogen and phosphorus. The inlet points are in each bay, and the flow then travels over to an effluent weir on the other side of the bay. The effluent then flows over the weir and into the secondary clarifier. The secondary clarifier receives the primary algae wheel treatment system's effluent. The effluent from the primary algae wheel treatment system flows into the secondary clarifier where there are 2 hoppers. Again, in the 2 hoppers are geyser pumps. There are 2 operating standpoints for the secondary clarifier. One being wasting sludge, which is set on an automatic timer control, where the geyser pumps will pump the sludge that is settled to the bottom of each hopper into the digester basin. Their skimmer will pump the scum off the top of the clarifier which then will flow over to the digester basin as well. The purpose of the secondary clarifier is to collect any sloughings from the wheels in the primary treatment system so they are not captured in the secondary treatment system. From here, the secondary clarifier's effluent will travel over to the secondary algae wheel treatment system. The secondary algae wheel treatment system basically removes the remaining nitrogen and phosphorus. As the primary algae wheel basin has, this has 5 bays, 45 wheels per bay. Again, these wheels are spun by blowers, which have diffusers run underneath each bay. The flow enters each inlet structure of each bay, flows through the algae wheel system and over the effluent weir on the other side of the basin, in which then it flows over to a tertiary clarifier. This clarifier, like the others, has 2 hoppers. Each hopper consists of a geyser pump, so you can waste the sludge to the digester basin. This clarifier also has a skimmer, so you could skim off the scum off the surface of the clarifier, which goes over to your digester basin. The purpose of the tertiary clarifier is to remove any remaining total suspended solids, to fine-tune your effluent, which then flows over to the drip irrigation dosing tank. The purpose of the aerobic digester is to receive sludge pumped from each of the 3 clarifiers. The blower is operated that breaks down the sludge to a point where you can shut your blower off, allow the sludge to settle out, and then you lower down a decant tube, which then flows your supernate gravity flowed over to your decant pump tank. The decant pump is activated by a float, so when this level rises, it trips the float. It then pumps your supernate over to your equalization basin. Once you get to a point where you cannot get any more water off of this basin and this level begins to rise to a point, then you call in a licensed septic hauler, and they will then pump out the concentrated waste sludge to a approved disposal site. Because this park is a seasonal park, there's sometimes low flow periods. For the low flow periods, there's a recirculation pump, which pumps effluent from the tertiary clarifier and constantly pumps back to what we call the anox basin. The anox basin will then pump into the primary clarifier. Basically, during those low flow periods, you will have a constant flow that keeps things moving through your entire algae wheel treatment system. The anox basin receives flow from the recirculation pump, which is being pumped from the tertiary clarifier. This basin is constantly aerated with a small air compressor to keep things moving, which flows back to the primary clarifier. The effluent from the tertiary clarifier and ultimately the algae wheel treatment system then flows to the drip holding tank. The purpose of the drip holding tank is to hold water for the dosing tanks that will ultimately discharge the effluent to the drip fields. The recirculation tank for the drip irrigation fields, the purpose of that is to flush out the drip irrigation field lines, to flush out any debris that's in there, any sand. The recirculation water is pumped back into the primary clarifier, which is ultimately put into the algae wheel treatment system again. From the holding tank is gravity fed into the dosing tanks. The purpose of the dosing tank is to access the filter socks, which prevent clogging of the field zones, the piping. From the dosing tanks, it gets pumped over through the flow metering tanks, which is used for monitoring purposes only, and then pumped out to the 2 drip zones. The treated effluent is pumped from the flow metering tanks and discharged out to the 2 drip irrigation zones, one on each side of me. The treated effluent then percolates through the sand.